Hello to everyone watching this video presentation. My name is Robert Schember, and I'm going to do a brief overview of what natural language processing is, cover why it's so difficult to implement, and explain how it's currently being used in the business world. So what exactly is natural language processing? In its most basic form, natural language processing is simply a cross between artificial intelligence and linguistics. Natural language processing gives a machine or a piece of software the ability to understand written or spoken language. Why is it important for a machine to be able to understand our languages? Because any machine that's going to be deemed intelligent must be able to communicate with us. Think about how we use our technology on a daily basis. If I need to add a doctor's appointment to my calendar, I might dictate to my phone and say something like, "Hey Siri, remind me to go see Dr. Jones at 8 a.m. on June 20th. The phone would respond with, "Okay, I added a calendar appointment for June 20th at 8 a.m. to see Dr. Jones." My phone just used natural language processing to listen to what I was saying, process it into a command, and then communicate a confirmation back to me. This is something we almost take for granted because it's so common now. Let's take a step back for a minute and talk about the beginnings of natural language processing. Natural language processing research began in the 1940s and the 1950s. The earliest attempts at using natural language processing for machine translation between languages were simplistic at best and used word-for-word translations. One problem with this type of translation is that there are many words that have different meanings based on the context in the sentence. These words are called homographs. One famous anecdote shows the problem quite clearly. When translating the biblical phrase, "The spirit is willing, but the flesh is weak," into Russian and then translating the result back into English, the phrase became, "The vodka is agreeable, but the meat is spoiled." You can see how the simple substitutions are correct for different meanings of the words, but the original meaning of the sentence is completely lost. Still other early attempts at natural language processing tried to create a list of handwritten rules that could be used to parse a written sentence. One other problem quickly became obvious. Natural languages are unrestricted and often ambiguous. Certain words can be used as multiple different parts of speech depending on their context. Take for example the sentence, "Baby swallows fly." The word baby can be both a noun or an adjective. The word swallows can be both a verb and a noun, and the word fly can be all three. Using one form of the words paints a picture of an infant ingesting an insect. Using the other form of the words gives us a small bird taking flight. While humans can easily tell that the correct meaning based on the context is the latter, trying to use a set of handwritten rules to parse this sentence fails in this case. So let's talk about the recent advancements in natural language processing. By recent, I mean since the year 2000. So in the 70-year history of natural language processing, these advancements have only recently been discovered. First of all, in the early 2000s, huge collections of written and spoken material became available. Collections like the Penn Tree Bank had syntactic and semantic information annotated with the written material, which meant new systems could be trained by comparing their parsed version of the written material to the annotations. During this period, computers continued to become much faster and even more powerful than ever, meaning almost anyone could own a powerful machine. This led to the commercial exploitation of natural language processing in the form of speech recognition, which further fueled the development of better algorithms. So let's talk about some business uses for natural language processing technology. Earlier, I spoke about how I could dictate a command to my phone and have it perform simple tasks for me, like adding calendar appointments. That's one example of commercial exploitation, but also how the smartphone business capitalized on the desire for humans to be able to communicate with machines. Amazon's Alexa is another example of the same technology. Some other uses for a business might be to search a knowledge base for answers to frequently asked questions. Think about how Google can get you an answer to just about any possible question. Expert systems are another example of business use of the technology. Doctors can input a list of symptoms into a program specifically designed to diagnose an illness and get a list of possible candidates in return. Consumer safety and product usability is another huge example of how natural language processing can help a business. Think about how dangerous it is to type into a GPS navigation system while driving. Instead of endangering yourself with distracted driving, you can now simply say something like, "Hey Google, take me to the nearest gas station." And without having to take your eyes off the road, your route is calculated and changed. Another example of natural language processing in real life is the impressive IBM Watson computer system. Watson was specifically designed towards answering questions on the Jeopardy game show. In 2011, Watson competed against legendary Jeopardy champions Ken Jennings and Brad Rutter and won by over $50,000, showing the world what natural language processing was truly capable of. Watson's technology was built using Prolog, a programming language that's very adept at natural language processing. Watson's full technical specs included 2,880 CPUs and 16 terabytes of RAM, with knowledge bases totaling just under 1 terabyte. All of the knowledge bases were loaded entirely into RAM to dramatically boost its processing speed. So what's next for the field of natural language processing? Currently, all effective approaches to natural language processing utilize the strengths of electronic circuitry rather than trying to mimic human neural function. This results in a thinking process that's nowhere near the robustness of a human brain. The development of algorithms that work more similarly to a human's thought pattern would definitely revolutionize natural language processing. But that may be many years down the road still, if we ever get there. Thank you for watching my presentation. The article here, Natural Language Processing, an Introduction, was my source for all information shown.